Thank you for coming back for the second part of the 1.3 video. This part we will focus on the adding and subtracting of fractions as well as a little bit more review of the multiplying and dividing. The first statement here, a blank is needed when adding or subtracting fractions, a common denominator. Again, this is needed when adding and subtracting fractions. Don't fall into the trap of finding a common denominator anytime you're working with fractions, only when adding and subtracting. Example 6, find the sum or difference as indicated. So first we see we have different denominators. So what we have to do is first find a least common denominator, meaning we need to find a number that 8 and 12 both go into evenly. So the easiest way to do it is take both your numbers and start by writing some multiples of those numbers, meaning take 8, 8 times 1, 8 times 2, 8 times 3, 8 times 4, so forth. 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is 24, 8 times 4 is 32, 8 times 5 is 40. Let's see if that's enough for now. Now we do the same thing with 12. 12 times 1 is 12. 12 times 2 is 24. We can stop right there because we already have a 24. That tells us that 24 is our least common denominator. We need to rewrite each of these fractions to have a denominator of 12. So we have to take the 7/8, and I'm going to rewrite this problem vertically. So we have 7/8 plus 5/12. But we need to write fractions that have denominators of 24. So we have to think to ourselves, okay, 8 times what number gave us 24? Right, that would be an 8 times 3. So we have to take 7 times 3, which is 21. 12 times 2 is 24, so we have to take 5 times 2, which is 10. Now that we have common denominators, we can add these two fractions. And the way we add fractions is we add their numerators together. 21 plus 10 is 31, and we bring down that denominator. Does this simplify it all? No, because 31's prime, nothing else goes into 31 other than 1 and 31. Therefore, we've added the fractions. Subtracting the fractions is the same idea. Instead of adding the 21 and 10, if it were subtraction, we would subtract 10 from 21. Again, we have to first find the LCD. Again, if we need to, list some multiples out. We have an 8 and a 5. 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is 24, 8 times 4 is 32, 8 times 5 is 40. Well, if we do the same thing for 5, 5 times 1 is 5, then 10, 15, 20, 25, 30, 35, and 40. And 40. So we have our 40, therefore we know the least common denominator is 40. So we have to take 9/8 and we have to subtract 4/5. But we have to change our denominators to 40. And so we have to say, okay, 8 times what is 40? 8 times 5. 8 times 5 is 40, so we have to do 9 times 5, which is 45. 5 times 8 is 40, so we have to do 4 times 8, which is 32. So now what we have to do different is take 45 minus 32. If you need to, use your calculator for that part. And when you take 45 minus 32, you're getting 13 over 40. 13's prime, the only numbers that go into it is 1 and 13, so we can't do anything else with that. Okay, next page. All right, so for this page here, I'm going to actually let you do these on your own, and then when you're finished, unpause the video and check your answer. So go ahead. Let's make sure you're on the right track. First thing we have to do is find our least common denominator. So we have our denominators of 10 and 5, and we write multiples, 10, 20, 30, and then we do 5, 10. We see that they both have a 10, so 10 becomes our LCD. So we have to write equivalent fractions. 7/10 minus 1/5. Well, we know that 5 times 2 is 10, so we have to do 1 times 2, which is 2. And 10 times 1 is 10, so 7 times 1 is 7. Go ahead, pause, and finish this problem. When we finish this, we make the subtraction. 7 minus 2 is 5, 5 over 10. We notice that 5 and 10 have a common factor of 5. We can rewrite 5 as 5 times 1, rewrite 10 as 5 times 2, and we get 1/2. Good. Now, just to make sure you're okay with this next problem getting started, we have 21 times 5 over 7. Well, 21 is what we call a whole number because it doesn't have a fraction. It might make it easier for you if you put a 1 as the denominator, and now we can rewrite this problem as 21 over 1 times 5 over 7. Now, pause the video and keep going with it. So we have to take our numerators, 21 times 5, which is what we have here, and 1 times 7, which is over here. We know that 7 goes into 21 evenly, which means they have a common factor. So we can rewrite 21 as 7 times 3. So I bring that 7 times 3 down here, bring down the 5. 7 divided by 7 is 1, so we can cancel those out. We're left with 3 times 5 is 15, and a 1, 15 divided by 1 is 15. So that's our final answer. Now this next one here, it says we want to divide 5/18 by 25 nines. And there is a little hint here that gives you an idea. It says if you have an XY divided by an AB, you can take XY and write it as divided by AB. So using that idea, we can rewrite this 5/18 as 5/18 divided by 25 nines. Now go ahead and finish this problem. Okay, so we start working through this problem. Remember, to divide fractions, we have to multiply by the reciprocal of the second fraction. So then we multiply straight across. 5 times 9 and 18 times 25. Again, always simplify first. We notice that 9 and 18 have a common factor of 9. So we rewrite 18 as 2 times 9. 5 and 25 have a common factor of 5. So we rewrite 25 as 5 times 5. Now we can say that 5 simplifies out with a 5. And then 9 divided by 9 is 1, so that cancels out. Now, when we go to multiply straight across here to finish, notice how we have nothing in our numerator, but we're left with a 2 times 5, which is 10 in the denominator. We need 10 to stay in the denominator, so in this case, we leave the 1 in the numerator, and where that 1 comes from is just when we were simplifying things, we said 9 divided by 9 is 1, so that leaves us with the 1 up there. So if there's a 1 in the denominator, it will get simplified out. But if the 1 is in the numerator, it must stay there because that puts the 10 in the denominator where it needs to be. Okay, that's all for section 1.3. So good luck with the homework and let me know if you have questions.